This tutorial is going to be another edition of my GMStudioPhysics series, and today we're going to be talking about how to make fixtures. Today we're going to talk about how to make fixtures using code. We already know how to make fixtures without code. That's what we do when we set up the shape of the object and talk about different properties like density and linear damping and that sort of thing. So this tutorial might seem a little bit useless to you because we're just going to learn how to do the same thing using code. But using code, there are a couple benefits we don't have otherwise, such as you can change friction of the fixture with code, which is a property that's not available to you without code. And another thing is you can actually bound multiple fixtures to an object, which we'll be talking about. And doing that will allow you to have the object be bound by concave shapes or complex shapes with more than 8 points. So that's a very good thing to know. So that's what we're going to talk about today. Without any further ado, let's get started. So I'll see you guys there. Alright then, here we go. We're back in our physics engine that we've been working on. So before I show you how to use fixtures with code, I'd like to just make a few changes to what we already have, just for a couple things that I'd like to change. So before we get started. Alright, so first thing, I want these objects are at a random rotation. I think that'll look much cooler. So if we go to the obj phi is our general object for all of our things. So if we change the creation event, if we set it up in the creation event obj phi, it should work for everything else. One thing about using physics in GameMaker is once you decide to use physics, you cannot change angle or location using the means that you're used to, which is very odd to start out with. You have to use all new variables that are coherent with the physics engine as opposed to the stuff you're used to, like v speed, h speed, x, y. You can't do that using physics. They have their own physics variables that you have to use instead. So in this case, we want to change the image angle, but we have to use a physics variable since we're using the physics engine. So instead of doing phi rotation, alright, which is the same thing. As you get used to the physics engine, you'll develop a list of variables that you have to transfer between using normal as opposed to physics. And I'll be talking about more than later, but phi rotation is the first one, and that's pretty much the same as image angle, only with phi rotation. So you want to go to random angle, so that's random 360. It's in degrees, not radians. At first I was afraid it was in radians, but I looked into that, and phi rotation is in degrees. Alright, so that will start off with random rotation. And now the other thing I want to take care of is, I was testing this out, and every time I tested out, the first object I create would be a square, first object I created would be a triangle, and then it would be a circle every single time. It will always be the same order of objects, which there should be randomized, so that's kind of weird that it'll happen like every time, but the way it works is whenever you're using random in computer program language, it's not actually random. It's impossible for a computer to come up with a random number on its own. What they do is they have a list of random numbers, and they'll read off the same list every single time. And it doesn't make any difference for the user, but it's not technically random. It's called pseudo-random. So the thing is, it's starting off at the same point in the list every single time, and I don't like that, because it turned out the same way every time I have to play the game. So the way you go about fixing that is making it start off at a random spot in the list, which I suppose involves another list, but the way you do that is do randomize. So by doing that, it'll start randomly at a different spot in the list every single time. Alright, so we're 3 minutes in and I haven't gotten to it yet. Maybe I'll edit a little of that, we'll see. Let's go ahead and get started. Alright, so we'll start with our circle. So all this information, the physics properties, we're going to do in code. So later in the tutorial I'm going to uncheck that, but I'll just keep it selected so that we have this as reference. Alright then, so let's go into the creation event, and now we're going to go create a fixture. So the method is, or function is fixture create, physics fixture create, and we're going to set fix equal fixture create. There you go. So then if we say fix, we're referring to the fixture that we are currently working on. First thing, we're going to set the shape. So physics fixture set, let me cheat a little bit here. Physics set box shape, that's what we want. Physics set box shape. I found out this button, you can press it to toggle the listing thing on and off. Nice. Alright, first thing, wait a sec, we're going to circle, I'm sorry, set circle shape. There we go. For the circle, it takes the fixture, what fixture you want to change, and the radius of the circle. In our case, the radius is 48. I looked at previously, but you can look in here, the modifying collision, and you'll see that that distance right there is 48, because the center is at 48, 48, and then the difference in the distance between the points are 48. So that will go and set the bound of the shape, and then we can move on to go through the properties. So we're going to go through them one by one. So that density, restitution, collision group, linear damping, and angular damping. Starting with density, physics, fixture, density, physics, fixture, set density, my bad. There we go. And fixture we're working with, and the density, which is 0.05. Let me try and fix up a little bit. There we go, now I can see what we're doing at the same time. Density is 0.05, like we have over here. And then we'll go with restitution, which looks almost exactly the same, only we change the density with restitution. Restitution. And that is 0.1. And then let's just make a couple more, 2, 3. Collision group. Let's type down collision group. And here we have linear damping, and that is 0.1. And then we have angular damping, and that is also 0.1. There you go. And now we have our fixture, but we want to say that this is the fixture we want to use for our object. So we need to bound it to our object. So fixture bind, I think. No, physics fixture bind. Physics fixture bind. There we go. Which fixture? Fixture we work on, fix. Which object? Us, self. So that's referring to this object. And now what we want to do is we want to delete the fixture. Physics fixture delete. This probably seems weird. We just spent so much time working on it. Why are we deleting it? Well, once it's bound to the object, the information is attached to the object. So we have this fixture, which contains the information, and then we have the copy of the information is bound to the object. So now we have bound to the object, we don't have to worry about this fixture, so we're just going to delete it, because at this point, all I'm doing is wasting memory. So that's that. Now we have a fixture for the circle, and we can go ahead and turn this off. The fact that we have a fixture bound to this will tell the system that we are using physics for this particular object. So I'm going to copy this, because we're going to use a very similar code for all other ones. And we should be able to go through this a little quicker now that I've explained those major points. Alright, so create, do this. You know what, I actually forgot something. Alright, so before we stop, this obj circle, its parent is obj5, which means it gets all the information obj5 copies over here. Well, obj5 is a creation event. Circle has a creation event. So which creation event doesn't use? Well, this is called, parenting is basically inheritance. It's called inheritance upper level program languages. And when both of them have the same function in them, then you would say that the one lower down the chain overrides one from higher. So having a creation event here, it'll override everything from here, but we still want this stuff. So let's go into circle. The way we'll get that information is go in here and we'll say invent inherited. So go through all this, and then do whatever our parent does. Alright? So that's just kind of important and gives you a little bit of knowledge of upper level programming stuff as well, so it's nice to know. So now we're going to copy this and use that code in our square. Go to creation event and over here. And I'll move this over. No, I won't. No, yeah, I will. Alright, here we go. So now, what we want to do is paste all that stuff. And now, what do we want to do differently? Well, it's a box, so we can't have circle shape, it's a box shape. So, box shape, and that's the same lingo as it uses over here. And box, it says the half width and the half height. So, our box is 96 by 96, so half its width and half its height are 48 by 48. So, that's how that will work. It'd be just fine. Now, Another thing I like to mention is that if I leave these out, it'll go with the defaults. And it just so happens that these are the defaults. When you first create a physics object, it will have all these values, or when you create this fixture, all the values that you get by default when you do it without code are the same as ones with code, with the exception of density. Density by default is 0. So we don't want ours to be static, so we're going to set it to 0.5. So density is the only one we really need to set up. If the rest is, since the rest is already default with the square, we don't need to really worry about that. And we're not going to worry about it with the other ones either. So now that we've got that figured out, we can copy that and move on. Triangle. This one's going to be quite a bit different, actually. So go to creation event. Alright, so this one's, I'll paste this. What type of shape do we have here? This one says shape. So in code, that's polygon. Polygon shape. So now we can add our points manually over here. So physics fixture add point. There you go, I'm on a roll. Alright, when I first went through this, I kept going to modify collision shape, and I looked at these points and I copied them down. The problem is, these points are relative to this top left corner of the sprite, but when we add a point in code, it's relative to our the reference point on the sprite. So in that case, that'll be that center. So the way I'm going to do it is I'm first going to copy these values down, and then I'm going to make an adjustment afterwards. So let's see, what are they? 088, 488, 9688. Alright, 088. Let me just write these down so I can remember. It says 488 and 9688. There we go. Alright, fix is the fixture we want to add to. So, which fixture? X, Y. And we got these. And this one's going to be 48, 8. And this one's going to be 9688. There we go. Now, like I said, these are relative to the wrong point. So what we want to do is we want to say subtract sprite x offset, which is the x value of its point that it goes by. So rather than writing that every single time, I'm going to write up here and create two variables. X off is equal to sprite x offset, and y off is equal to sprite y offset. So I believe this is better for memory as well, because then it's not going through the trouble of retrieving every single time. We just have a variable. So we're going to subtract the offset for each of these to make it work. And this may seem more complicated, but I don't want to manually subtract it for each one. That would be a hassle, so therefore I'm doing it like this. So there we go. Alright, now I have it set up for the triangle. This should work just fine. And then I'll unclick uses physics. Then I believe I forgot. I forgot to unclick uses physics for the square. Okay, now our last one, the cross. Or well, we're gonna go through the result as well. So our second to last one is the cross. Create. Let's go through this. Or let me drag this over here again. All right, paste. Oh gosh, I don't have paste anymore. I don't have copied anymore. Go over to triangle, copy that, and then we'll go back to the cross and go through there. There we have it. So now we're going to have different points. Remember in the beginning how I talked about how you can bound multiple fixtures or bind multiple fixtures to an object? Well, we're going to do that here because our cross is a concave shape. So we're going to bound multiple fixtures to it to make it non-concave. So the first one we're going to bound is this big rectangle here. So over here it shows that. So we can just use the box for that. So this is going to be a box shape, and half its width is 96 and half the height is what? 16. Okay, half the width is 48, half the height is 16. My bad. Okay, so then we have this fixture all set up. Then we're going to go through this again. This fixed variable is no longer being used until it's deleted over here. So we're just going to set it over to a new fixture and set it up for that. So this one's going to work, since these are still boxes, but they're going to be off-center, so we're going to have to just make them a polygon and set the points individually. Alright, so we have this. We now have this rectangle over here, Now we're going to do this square up here. So memorize these points then. 32, 32, 32, 0, 64. Actually, I think I'm going to do this a little bit differently. There. 32, 0, 64, 0, 64, 32, 32, 32. There you go, that's easy to remember. So, okay, let me just, 32, 0, 64, 0, 64, 32, and 32, 32. There we go, got all our points. Up here we're going to go physics, fixture, add point, and then fix 32, 0. Alright, copy, paste, paste, and paste. And this one is 64, 0, these are 32 and 32, and then this one up here is 64. Bingo. Fixture number 2 is done. Now we need a third one for this bottom part. And you'll notice that each individual point is the same as the previous one, except it has what? 64 added to the y. So we can just go ahead and copy and paste all this, and we can add 64 to all the y's. Okay, now I have our 3 shapes, and of course we mustn't forget about this offset thing, which still is valid here for the same reason. So I need to, probably should have done this earlier, need to apply it to every single x coordinate. You could have went through and figured this out yourself if you wished, but this is actually, I find this easier to set up in variables and subtract it like that. Have the computer do the work for you. Okay, so now we have our 3 fixtures all set up, and this should make the fixture of the box look much nicer, or the cross look much nicer. Okay, let me go ahead and copy this from the triangle one more time because we need to set it up for the solid. All right. This one doesn't have a parent, so we can take away the event inherited part. So we'll take away that part. Whew. Alright, now, the only difference, this one is that density is 0, and like I said, the default density is 0, so we can go and take that one away actually. So now it's a static object like it's supposed to be, with density 0, and it's a box, so we can go and set that up. So it's a box shape, it's that box shape, and it's a small box, 1616 actually is the half width, half height. Pardon me. Alright, so let's see. Oh yes. The only property that we can't set up over here is fixture. Or I think there's like 1 or 2 other minor ones, but fixture, I said fixture. Friction. Friction is the only property that we can't set up over here. I think there might be 1 or 2 other minor ones, but I feel like friction's a big one that you would want. Because if you are making a platformer, like I'm actually going to show you how to make a platformer in a later tutorial. If you're making a platform in this engine, you're going to want to have friction, or you're going to want to have control of friction, because if you, let's say, apply a force to your player, then there's nothing to stop it. It's actually Newton's first law. If you have an object and you apply a force to it, then there's nothing to stop it. Then it's just going to stay in motion. An object in motion tends to stay in motion. So you need something to be able to stop it. And in the real world, there's always stuff to stop. There's air resistance and friction. And so in here, we're going to want to have friction to stop it, because then if it's moving over ground for a certain amount of time, we're going to have friction naturally slow it down, which is nice. And by having control over friction, you can also do some neat stuff like change the surface. Like if it's ice, you can make decrease friction, making the player slide more, which is just very neat. So let's show you how to do it then. Physics, fixture, set, friction. Fix, how much friction? Well, friction can be numbered between 0 and 1, where 0 is no friction, like really, really slippery ice, and then 1 would be super friction, like you're walking on tar, your feet are practically stuck to the ground. So we're just going to set it at 0.5. It won't make too much difference in our engine, but I really want you to know about it because it's useful to know. So I believe that is all for our program, except I need to uncheck uses physics. Let me just make sure I didn't forget any of these. No, 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 no. Alright. So now, oh, jeez. Now we're pretty much done except for this problem. Line 4, triangle. Wrong number of actions in script, you go away. Number 4, fixtures. Oh, yes. Polygon shape. You set the points down here. It doesn't require any information over here. You can see that down here. Just a fixture. I wonder if I made the mistake in the cross as well. Cross. No, I didn't make that mistake. Okay. Alright, here we go. Oh, when I was testing out, I added this. I also turned off gravity. Do I still have that? I sure do. Okay. We don't really need gravity. So there we go. It's working nicely. It's not good, is it? Okay. I screwed up somewhere, was what this is telling me. The triangle looks terrible. The circle looks nice. And, yeah, so I turned off gravity just for testing. So now this is how it looks like in space. Hey guys, I'm back. So as you noticed, I had some technical difficulties back there. The recorder cut off for some random reason. So this is 2 weeks later. I have just begun editing the video and I had noticed that it is screwed up. So I will have to go ahead and record this to complete the tutorial. The problem is I have actually completed the entire series already. So this engine right here is from the end of the series. You see that this is a little different. We're going to be adding joints soon, so you have to look forward to in the following tutorials. But anyway, but I don't think it should make any difference for this particular tutorial. So I'll just go outline stuff that were cut out and then we'll move on. So there are 3 things that we need to fix. As you noticed when I was testing it out, the gravity wasn't working, so I'm going to take care of that before I forget. So you're going to go under physics and make sure that's set to 10 or whatever, just to make sure that gravity's turned back on. And then number 2, when I was making the tutorial, I sort of, I guess you could say I panicked because I had no idea what the problem was. So I went ahead and showed you guys how to make a physics debug system. That's what I would do if I had a problem. I wouldn't know. I would set up the debug so that I could see what's happening. It'll just make an outline of where the fixtures, so that way you can see what's messed up about the fixtures. So I had assumed that the triangle fixture was screwed up, so I drew the debug to see if that was true. Alright, so the way we're going to do that is we're going to go set up a new variable. So go under control, set up a new variable, global.debug. Set equal to false initially, just because, yeah, that's what we're going to do. And we want to toggle between on and off when we press space. So I put down this code. Exclamation point means not. So the variable becomes whatever it was not previously. If it was true, it's not true or false now. If it was false, it's not false or true now. So that's that toggle works, just like that. And then we are going to go under obj5. So this is the parent of circle, square, triangle, and cross. So what we put in here counts for them as well, because we don't have a draw event to override the phi. So anything we put in the draw event right now will count for all of those things. So I went ahead and added this code. I went ahead and added the draw set color red to make sure that it's red. I actually just added this, so this won't be in the future tutorials. This code you won't see in the future tutorials, because I didn't add it in there. But because if it's black, you can't really read it. It'll change our impulse line red as well, but oh well. So okay, I haven't said anything about what this does. So here's an if statement saying that if global.debug equals true, we're going to go ahead and do this. So color is red now, and then we're going to say physics draw debug. There's a more complex version of that function. I'm going to be talking about that in a later tutorial, but this is the simple version, and what it does is it'll draw an outline of what our fixture looks like, which is really useful when you're trying to see what's exactly happening with the physics, not just what's visually happening in front of you. So now I have physics. So now that we have our physics debug thing set up, maybe we can play and find out what the problem is. Play the game and find out what the problem is. So I can create stuff, and it looks weird. I actually recreated the bug that I was having. So if I press space, debug is now on. You can notice that there's red outlines with everything, and you also notice that this one's now in sections. So let's see about a triangle. Triangle looks normal too. So what's the problem? Well, if it's not, the problem's not with one of our physics objects, it must be with this solid wall. So because this one's not considered a physics object, so this one doesn't have debug drawn around it. If it had, you notice that it actually is kind of odd. So let me go and show you the problem. Okay, so let's go into solid and let's see what we did. So I used this fixture set box shape. Same one as use a rectangle. Seems to make sense. The solid is 32 wide, so here this asks for a box shape, which we're box shape obviously. It's 32 wide and 32 high, so our half width and half height, you can't see my mouse down there, half width and half height is 16, 16, seems to make sense. Well, let me tell you what's wrong with that. This is created around the reference point for the sprite, and we have a reference point for sprite set to the top left corner, so it will make it around the top left corner. It's the only object I have it set to that, which is why I probably overlooked it. If we had this set up, it would be the equivalent of having it look like that, which is why it's screwed up, which is why it was looking weird. So there are two things you can do to fix that. Number one, the easier way I guess, is you can set this centered, but I didn't want to do that because then, like, if you set this to center, you notice that all of the objects in our room are shifted now. See, because they have a new reference point, and I don't want to go through the hassle of moving them all and changing the grid and figuring that out. So I did the more complicated coding way. Okay, so instead of setting a box shape, we're going to set it to be a custom point by point thing, which I'm not sure I remember the function exactly. Let's see, physics fixture. Let's see, that one's box shape. I think it's polygon shape, maybe. No. Physics fixture. Set polygon shape. There we go. There we go. Okay. All right, and it's just with it's which fixture we're dealing with. This is the only parameter. Actually, well, I don't really need to explain this. I've already explained this for the cross. Okay, and then we'll just go through all our points. So if we click use physics, modify collision shape, that's, let's see, 0, 0, 32, 0, 32, 32, and 0, 32. Got that? I'm not sure I got that. We'll figure it out. Okay, so physics fixture add point. Fix our point is 0, 0. The first one's easy. Physics fixture add point and fix, and next one 32, 0, 0, 32 needs to be clockwise. That'll be 32, 0. Yeah, okay. And then we go down to 32, 32, and I'll just start copying this stuff. 32, 32, and then we go to 0, 32. Okay, now we have that set up, and that should fix our problems. Alright, let's create some stuff, and it looks pretty good. And its collisions look good everywhere. Nice. Alright, now it allows us to reflect on this tutorial. Why do you care about fixtures? Okay, so the main thing is this cross. Like as you notice when I press spacebar, you can see it's made of 3 fixtures, and this area between the individual crosses is not solid anymore. It's empty space, which is good. So something like that can happen, or I can make it better. I found a cross. There we go, and that is now possible, which is kind of neat. Which it's just a little thing, but it makes our physics that much more accurate, and it's something new to know how to do. So if you have other concave objects, you now know how to use a slightly trickier method to make it an accurate physics representation. Other thing we talked about, big idea I guess, is these solids have now a fixture setting, which is hard to demonstrate in this tutorial, so I'm not really going to try. But if you are making a platform or something like that, it's very nice to be able to control fixture, because then you can easily create surfaces that are ice, so they're slippery, or you can make them extra sticky or whatever, just extra things that you now have control of. So that is in this tutorial. Thank you so much for watching. If you found it helpful, I would appreciate if you have to like. It helps out my channel, makes it more makes it easier for other people to find, and I also like if you have to comment, please, because, well, if you liked it, obviously I'd like to hear it. If you use this project, I always like seeing how this put to use. And if you didn't like it, maybe you thought it was a terrible video, I did a terrible job explaining it, I stuttered too much or something like that, please tell me. I am open to criticism. I want to, any information I can use to make our tutorials better, I appreciate. So if you have negative response, let me know so I can work at making it better. I'm always in the market to make my videos better. So I have several more tutorials coming. I got this series that will be coming to close in the next 3 or 4 tutorials, and I got another one coming after that that's actually all recorded and set, so that we'll move straight into that. So if you want to be the first person to know about it when I make new tutorials, the best way to do that is to subscribe, and I have about 15 seconds before this video is over. So thank you for watching, and I'll see you guys next time. I really appreciate seeing you guys again. Alright, so you can see how they interact here. When you move one, it acts as if it's a pulley system with a pulley there. There you go, you now know how to create a 3D isometric effect, and it looks really neat. I remember how happy I was when I first figured this out. I forced all of my roommates to look at it.